One kind of the attacks for RSA is chosen ciphertext attack, which is CCA. CCA is using or take advantage of the following property, which is encryption of M1 or message M1 using public key multiplied by encryption of message 2 using public key is equal to the encryption of message 1 multiplied by message 2 using public key. This is the property that the attackers use to decrypt the encrypted message or to know the encrypted message. So, for example, we can decrypt using C equal M to the power E mod N, which E is here is the public key. E is public key here using the CCA as follows. Don't forget that C is equal to the M to the power E because we are using the public key to encrypt our data. Now we compute X equals C, which is the ciphertext multiplied by 2 to the power E, and the E here is a public key mod N. After that, we apply the data or send X to the encryptor, and we return back Y. Y will be X to the power D mod N. Now using the above relationship, which is X equals C mod N, which this one, X equals C multiplied by 2 to the power E mod N, we can say, using that property, we can say C mod N multiplied by distribute. C mod N multiplied by 2 to the power E mod N. C mod N multiplied E to the power 2 to the power E mod N. Now we know that C equal M to the power E mod N. So M multiplied by E to the power N and 2 multiplied uh, 2 multiplied by 2 to the power E mod N. Now we can combine these together back. We multiply 2 and the M both to the power E. Now we can guess that Y here is 2 to the is 2 multiplied by N. We can know now make sure that because of this relationship, we can know that 2M is Y, simply Y. We know Y because we already calculated it. Now we can easily calculate M, where M is Y divided by 2. Okay, let's take an example. I will share my camera here. Let me share my camera. Now, let's take an example. For example, if we have the Alice and Bob together, Alice, and this is Bob, and we have the public key, private key pairs. This is the public key, PU, which is, I will use the relationship immediately. We can encrypt using M to the power E mod N and C equal M, which is the text to the power E, which is 7 mod N, which is 33. 7 and 33 using also the private key, which is C equal or M equals C to the power D mod N. And we are going to use that one we have proposed before, which is C to the power 3 mod 33. We already in this lecture previously, in the previous slides, we have proposed P equal 3 and the Q equal 11 and N equal 3 by 11, which is 33. We have seen that and how to calculate these keys before. Now we are going to use them. Now I want you to concentrate with me. I have divided the paper to two parts. This is the hidden part, hidden. I cannot see this part. and this is public part. This is public. What I'm seeing here is a message commutating. The message is 20. Suppose this is the plain text, which is corresponding to letter E or letter F, anything, plain text. This is just a public number. I want to know, this is just, sorry, this is not the plain text. I can see the cipher text. The cipher text is 20, but I don't know 20 is what. This is just the cipher text. I have here is the plain text, but I cannot see the plain text. It is hidden. I cannot see it. I can see only the 20, which is cipher text. And also I can see the public key. I can see the 33. All of these parts, I can see them. To the right, I cannot see. To the left, I can see. Now I calculate x equal to what? Equal to 20 multiplied by 2 to the power 7 mod 33. Mod 33. If you use the calculator, it is easy to confirm that x equal to 19. Now I am applying 19 to the encryptor to see the response. So the encryptor will take X and encrypt it using this one, Y, and calculate Y is equal to 19 to the power private key, which is 3. I cannot see that, but I will tell you what I'm seeing. It will do that, mod 33. This is going to give us 28. Now I cannot see 28. Now I can see 28. 28, I received it from the server. I just know that y equal 28. I know that x equal 19 and y equal 28. Now using the relationship that we have derived in the slides, this relationship is like that. X equal c mod n multiplied by e 2 to the power e mod n. This is m to the power e mod n multiplied by 2 to the power e mod n. This is going to give me 2m to the power e mod n. Now I know that y, because this is x equal to m to the power e mod m, this means this is y. This is y. I know that y equal to m. This means that m is equal to y over 2, which is 28 over 2, which is 14. 14 is the secret text. This is the secret text. This is the secret text. How to make sure this is the secret text? We can use simply we can use that simply by this is the secret text. The cipher text equal to the m to the power e mod 33, and this is the plain text. I mean, this is the plain text, and m equal to what is equal to 14 to the power e mod 33. If you calculate this, no, this is 20 to the power e mod 33. Okay, let us see this by calculator. Stop sharing that. I can use my calculator here, it's better, but I don't know if they have mod or not. Okay, let's take stop here and share my screen. Share my screen. Again, I can have the calculator and 20 to the power 20 to the power e, which is the public key. Now the public key is what? The public key is 7, okay, equal mod 33, sorry, equal 26. So, no, this is not correct. It should be 20. No, I mean, no. I think I have to use the private key. So 20 to the power Let me check the private key, which is 3, not 7. And this is mod 33. This is 14. Yes, this is 14, exactly. Now I can see that 14, this one is to the power D, M to the power D, which is the private key. Now, yes, this is okay. Let me share again my camera to see here. I mean here, this is D, not E. So this is going to give us 20 to the power D equal 20 to the power 3 mod 33. 3 is a private key, so now it is 40. So now I'm sure that 20 and 14 is the plain text and the 20 is the cipher text. I can guess the 14. I can calculate and get out for 14 without knowing the public key or anything. Just apply some technology, some equation, and using that equation, using that equation, I can guess the values of the secret text or the encrypted text. I can guess the plain text. That is one of the attacks is common. CCA is common weakness for RSA. That's all for today, and thank you very much. Goodbye.